So now I'd like you to check and see if your predictions were correct by using your calculator to graph the transformations below. On each one of these exercises, you're going to start out by graphing y equals x cubed, which is the parent function. I know we've talked about that before, talked about parent functions and how you can do various transformations on them. So on your y equals x cubed parent function, that's your cubic function, your vertex, remember on the previous page, we talked about how our vertex is at the origin at 0, 0. And then it has points at 1, 1, and at 2, 8, and at -1, -1, and -2, -8. Okay, so you can go ahead and sketch that function. Okay, and remember it should have that S shape to it. And then go ahead and type into your calculator the next two functions and graph those. So hopefully your graphs look like mine. I graphed x cubed plus 2 in purple, and the vertex, that's what would have been at the origin, was shifted up 2 and is now at 0, 2. On the third example, x cubed minus 5, it was shifted down 5 with the vertex at 0, -5. So notice over here, you've got your parent function in black, you've got your purple function that has the same general shape to it, it's still a cubic function, but it was shifted up from the origin 2. And then your function that's in red was shifted down from the origin 5. Okay, so notice what happened here. X cubed with a 2 on the end, x cubed with a -5 on the end. How did that shift the parent function of y equals x cubed? Think about that for a second before we move on. Alright, so again, I would like you to first sketch this parent function. Just like before, the vertex, that's that middle point, is at the origin. When we go over 1, we go up 1. And when we go over 2, we go up 8. So then go backwards, go left 1, down 1, and go left 2, down 8. Okay, so that is, in black again, our parent function. It's got that S shape. And now I'd like you to use your calculator to graph the other two functions in different colors and think about how the changes to the equation affected the graph. Okay, so I graphed x plus 3 cubed in blue. Notice how it is shifted from the parent function. And I graphed x minus 2 cubed in green. Notice how it's shifted from the parent function. Hopefully yours look the same. Alright, on this last exercise, again, I would like us to first graph the parent function here. So from the vertex, we go over 1, we go up 1. We go over 2, up 8. We can go to the left, go left 1, down 1. Go left 2, down 8. Connect those. Again, there's your cubic parent function. Alright. And now I'd like you to go ahead and sketch the other graphs. Definitely use your calculator to help you on this one so that you can notice these patterns. Sketch the second, third, and fourth, and notice what happens to the cubic function. Okay, so hopefully your graphs look like mine. I graphed y equals 2x cubed in kind of that reddish brown color. Notice that it is taller and skinnier than the parent function. So think about what that 2 did on the front of it. I sketched y equals 1/2 x cubed in an orangish color. And notice that it's a little bit shorter and squatter than the parent function is. So think about what that 1/2 on the front did to it. Then lastly, I sketched y equals -x cubed in this purplish color. Notice the way that looks compared to the parent function in black. Also notice all of these, this graph got a little bit cluttered, all of these go through the origin. So the vertex, which was at the origin, the vertex didn't change. What did change when we were changing that value on the front? I want you to take a second to think about that. So hopefully you came up with the same answer as me. It was vertically stretched, and think about when it was vertically stretched. Hopefully you're thinking same thing as it was for the quadratics. When a is greater than 1, it's going to be vertically stretched. Vertically shrunk, just like on quadratics. When a is less than 1, doesn't matter if it's positive or negative, just if it's a fraction, if the absolute value of it is less than 1. And flipped, again, just like in quadratics, when you have a being negative. Okay, so I want to summarize our findings from this exploration above. This general equation hopefully looks very familiar to you and hopefully looks a lot like the way it looked for quadratics. The only difference is that this is now cubed. X minus h is cubed rather than squared the way it was on quadratics. Okay, so when a is positive, the graph shape will look like this. It will be opening upward. It will be opening normally. When a is negative, it will be flipped over and it would look like this, the way that purple graph looked like. A graph is stretched vertically, just like always, when a is greater than 1. Doesn't matter if it's positive or negative, so let's put some little absolute values around that. And it's vertically shrunk if a, the absolute value of it, is less than 1. So we ignore the negative if there is one, and we just want to compare it to 1. A value of h causes a shift in the horizontal direction on the x-axis, and a value of k causes a vertical shift in the y direction, just like always. The vertex is hk, again, just like always. We always think backwards for the h and as is for the k.